Hi everyone! Today I'm excited to share how nature has inspired groundbreaking innovation in sustainability. My presentation, Inspired by Nature, Sustainable Innovation to Combat Climate Change, explore biomimicry-driven solutions that help mitigate environmental challenges.
Have you heard about biomimicry? The concept of biomimicry was coined by scientist Janice Banyas and is derived from the Greek word bios, means life, and mimesis, to imitate. Biomimicry main goal is to develop innovative design by mimicking living organisms that have evolved over 3.8 billion years to survive efficiently in their environments. How do designers apply biomimicry? There are two main approaches. Firstly, top-down approach. This is when designers start with a problem and then look to nature for a solution. Second, bottom-up approach. This is when scientists and designers already have biological knowledge and use it to inspire new design. These two approaches show how nature can guide us in different ways, whether we start with a challenge or with a biological discovery. Biomimicry isn't just about copying nature appearance, it works on different levels depending on how deeply we integrate nature wisdom into design. There are three main levels of biomimicry. Firstly, organism level. This is when we mimic a specific organism or a part of it. Second, behavior level. Instead of copying an organism's physical form, this level focuses on how organisms behave and interact with their environment. Thirdly, ecosystem level. This is the most complex and ambitious level where we mimic entire ecosystem. The idea is to create systems that are self-sustaining and regenerative, like how forests recycle nutrients or coral reefs support device marine life. Remember, biomimicry is all about being inspired by nature. So what key sustainability lesson can we learn from the natural world? First, waste doesn't exist. One of the nature greater lessons is that nothing goes to waste. In a forest, fallen leaves decompose and enrich the soil, animal waste nourishes microorganisms, and everything is recycled back into the ecosystem. Second, efficient is the key. Nature is a master of doing more with less. Every structure, process, and system is optimized for maximum output with minimum resources. Take bee for example. They build honeycombs in hexagonal shape because it is the most efficient way to store honey while using the least amount of wax. Lastly, everything is connected. In nature, no species exists in isolation. Plants, animals, and microorganisms form complex networks where each plays a role in supporting the ecosystem. The world today faces critical climate challenges, rising global temperatures, and extreme weather events, reminding us that the world needs our action now more than ever. According to World Resources Institute, carbon dioxide comprises 74% of greenhouse gas emissions. In 2021, the global building sector was a major energy consumer, accounting for 30% of the final energy demand, primarily for operational needs like heating and cooling, including the energy for producing construction materials. While the world is making progress in expanding renewable energy, fossil fuels still dominate the global energy supply. In 2023, fossil fuel and nuclear account for 70% for the world's total energy production, while renewables only contribute around 30% to global electricity generation. How does biomimicry can solve climate change? To tackle these challenges, we need smarter, more sustainable solutions. Biomimicry offers a way forward by looking to nature for efficient, climate-friendly design. Fortunately, we already have real-world examples where nature's genius has inspired groundbreaking innovation. Let's look at two case studies that demonstrate how biomimicry is helping us reduce energy consumption and improve renewable energy efficiency. In 1997, architect Mick Pierce was given a challenge. An investment group in Harare, Zimbabwe wanted him to design the country's largest office and retail building, but with one major constraint. They wanted to minimize air conditioning costs. in a region with a high temperature. This raises a critical question: how do we design a large building that can cool itself naturally? Pease found the answer in nature in termite mounds. This is the termite mounds. Millions of termites live inside this structure. Termite mounds can reach impressive height depending on the species and environment. African termite mounds can grow up to 26 to 38 feet tall. Meet the Eastgate Center, designed by Mick Pierce, which is the largest commercial building in Zimbabwe. Although termite mounds appear solid from the outside, they are actually full of tiny ventilation holes that allow air to flow freely. The Eastgate Center is built using concrete and brick, material with high thermal mass that naturally regulate temperature, just like termite mounds. Its thick concrete wall absorb heat during the day and release it at night, helping to maintain a stable indoor temperature without the need for energy-intensive air conditioning. During the night, the outside temperature drops, cool air flows in, pushing out the stored heat from the day. During the day, the large central chimney creates a closed convection circle. Cool air enters through lower vents, circulates throughout the building, and pushes warm air out through chimney at the top. This natural process keeps the interior comfortable, reducing the need for mechanical cooling. As a result, Eastgate uses 35% less total energy than the average consumption of 6 other conventional buildings. It also saves 10% of the total building costs compared to those buildings with full HVAC. Another notable invention inspired by nature-based solution is wind turbine. Thanks to John Dabiri, one of the biggest challenges with traditional horizontal axis wind turbine is the large amounts of space required between them to minimize turbulence. This spacing limitation reduces the efficiency of wind farm. Looking to nature for solution, Dabiri noticed that schooling fish can swim together without interfering with one another. Just as fish fins interact with water currents, the vortices created by this turbine enhance the performance of downwind turbine. Applying the same principle, he designed wind farm using vertical axis wind turbine that can work together in close proximity. You can see that the traditional horizontal axis wind turbine interfere with each other. Compared to the vertical design, it will increase energy capture and significantly reduce the land required for wind farm installation. As a result, wind farm power generation has increased from just 2 watts per square meter to up to 10 times more power from the same land area, making wind energy more efficient and scalable. In the early 2000s, marine biologist Frank Fish made an unexpected discovery while studying humpback whales. He noticed that their flipper had bumps, called tubercles, along the leading edge. His first reaction: that doesn't make sense. Smooth surfaces should be better, right? Look at the A-plan wings, they are always straight. But as he looked deeper, he found that this bump actually helped the whales swim more efficiently, allowing them to turn easily and glide through the water without losing the speed. Curious about how this could be applied outside of nature, Fish collaborated with mechanical engineer Phil Watts to test the aerodynamics of these wheel-inspired bumps. The result was surprising. The blades with tubercles perform better than smooth blades. Tubercles help keep airflow attached to the blade for longer, delaying stall and letting the blade keep producing power even at a higher wind speed. They move through air more efficiently, reducing drag. The bumps break up airflow into smaller, more organized streams, reducing turbulence and making the blade more efficient. They were also quieter and more stable even in a turbulent condition. Excited by their finding, Fish and Watts teamed up with entrepreneur Stephen DeVore to bring this breakthrough to real-world application. Together, they founded Will Power, a company dedicated to transforming wind turbine technology using tubercle-inspired design. Will Power developed the first wind turbine blades with tubercle, and the impact was immediate. The result was up to 20% more power from the same wind, quieter operation due to reduced turbulence, improved performance in varying wind conditions. Today, tubercle technology is used in industrial fan and HVAC system and A-plan wings.
The world is facing the impacts of climate change, and nature already holds the solution we need. Biomimicry isn't just about copying nature material and structure, it's about understanding how biological systems work and applying those principles to solve human challenges. These ideas have existed for millions of years. We don't need to reinvent them, just learn from them. By embracing nature efficiency and adaptability, we can create practical, sustainable solutions for a better future. So, ask nature.
ご覧いただきありがとうございます。